turns me on. Good day, sunshine in the backseat car. I wish that road could never stop. Down on the ground.
All right. Thank you very much for inviting me. It's incredible, all these people coming to listen to me. I have to say something smart. I'm not sure I will, but I will try. The title that I did not write really, but the organizers said, this is a title. I said, yeah, okay. And can we create music with AI? It's a great title because actually in 1958, this is what people did. So this is an extract of the, it's not very clear, Iliac Suite for String Quartet, 1956. This is all generated with Markov chains. And Markov chains are not very far from neural networks. So it's AI. So yes, the answer to the question is yes. AI can be used to generate music. And thank you for coming. And let's have a drink. This was 62 years ago. So maybe another question is music the most interesting problem for AI? And I think the answer is yes, also. I will try to say why, and I will try also to give you some examples, because so that you have maybe concrete sound in your head. And so the first thing I want to say that, of course, everyone talks about AI, actually specifically machine learning all the time, these days, right? And machine learning is really invading all the domains of activity of humans, really almost all of them. But what's really clear that the only thing that these models can do is to solve problems which are well-defined. So what does it mean it's well-defined? In fact, with machine learning, it means something very precise. It means that somehow the problem you're trying to solve, there is a well-defined function in the sense of mathematics that takes as arguments, the data of the problems. And this function, first of all, exists, and it's not obvious that it's always the case, and it has to be differentiable. So it's a very specific kind of function, right? But it turns out that it's very specific, but it works incredibly well in a lot of domains, because all these domains are well defined. So driving cars, function is how many people you kill per second, right? Very well defined. And you want to optimize, well, in this case, minimize, of course. Works perfectly well, works much better than humans. Recognizing faces, very well defined. It's the right face or it's not, right? So very easy to define. Tumors in a brain also, because you have what's called a ground truth. You have images and you know that this is a tumor, you know that this is not. Playing chess, playing Go, very well defined. In chess, you win when you kill the king of the opponent. That's fantastic. And in fact, these techniques are so powerful that even when you don't have this, but you have some kind of approximation, it still works very well. Great. Lots of jobs will be killed. Great. Fantastic. The problem with music is the problem also with art, is that there is no such thing as a well-defined function anywhere. Like for centuries, maybe more, people have really asked the question, what is a nice melody? Well, no one knows. What is a nice photo, a nice painting, a nice story? So we know that some stories are better than others, or maybe we don't agree, but we have some ideas, but we have no idea what is a function. So in all these cases, it turns out that AI and machine learning is also have been used actually for a long time, again from the 56 actually, but also recently with the new technologies of deep learning. And I've started to investigate all these domains. And there were some spectacular results in 2016 actually. So Morgan is the first movie trailer generated with AI from a full movie by Watson AI. So a trailer is you have a movie which is like this, 1 hour and 30 minutes, and you want to make a movie which is 5 minutes, and the constraint is that you can use only scenes from the original movie, but you have to put them in such a way that if people look at the trailer, they want to rush and see the actual movie. And so it's very hard, it's very important for the industry, and that's a very important result. They solved actually only half of the problem, but still, it's quite spectacular. The movie script was generated entirely by recurrent networks, and by a guy, Ross Goodwin, who is not a researcher, who is a journalist. So it really means that these tools are not only like things in labs, but they're becoming more and more accessible. There was this Rembrandt painting here, generated by Microsoft AI. So this is maybe more like a pastiche, but it's very nice. If you look at it, it's very, very exactly like Rembrandt, although it's not. So it's really impressive and makes you think about what is creativity and all that. But this was 2 years ago. And you have heard about deep dream images and videos and style transfer. I will come back on that. Even cooking now, there are serious people doing using AI to generate to invent new recipes, and trying them in very famous restaurants in New York. So it's really AI is invading this domain, but you have to know that there is no function to optimize. So what's going on really? What are they trying to do? So I want to talk a bit about that. So in fact, in all this list I showed, there is no music, but in 2016 also we made the first musical, in French, comédie musicale. I don't know if you have this here. We don't have that much in France actually, but it's a thing that British people like a lot. So it's like a theater play, but everyone is singing, right? It's boring, I know, but what can I do? So Beyond the Fence is a musical where everything was done by AI, the pitch, the story, the songs, the lyrics, and at the end it was played by a troupe at the Covent Garden. This is just an extract to show that it's real.
That does not make me freaky or weak.
This is one of the songs.
I love the other one.
Oh, okay, it sounds like a real song. And the score of the song was done by 2 guys and software, an AI. And what's interesting that this thing was showed at Covent Garden for real for a few weeks, and then the critics came and wrote papers. And then there was an analysis of the critics, right? So the whole loop was done, and an interesting critic, I just took this one, he said, I enjoy this song, which is the one you just heard, which reminded me, that's the key word here, reminded me of Gilbert and Sullivan's, who are very famous musical songwriters. But still, it reminded me, but it's not the same. It's not plagiarism, something new. And so this experiment, and many others since, have opened the way to trying to use AI in creative ways. But again, what is it that we try to optimize? And now I want to mention the work what I'm trying to do is to tell you that the problem is really very much not well defined at all. First of all, I'm saying there is no function that tells you this is good, this is bad. This is ground truth, this is not. In music, no such a thing. So the second reason why it's really hard and interesting is a paper by, well, it's not a paper, but it's a fundamental reason. It's called social pressure. And I want to quote this paper, which I think is fantastic, by Salganik and Watts in Science 2006, called Experimental Study of Inequality and Unpredictability in Artificial Cultural Market. Okay, sounds a bit boring, but it's really great. Because when you read the paper, you wonder really whether you exist or not at the end. Because what did they do? They wanted to study whether when we like a piece of music, it's us or it's the others, right? So the role of social pressure. So we all have social pressure because we talk to each other, we listen to radios, to Facebook, whatever. So social pressure is just the way that we are not alone on Earth. If we were, there wouldn't be any social pressure, but there is a lot of social pressure. So what they did, I was trying to go very fast, is that they took a lot of music, songs that no one knew, nothing well known in there. And basically they made two groups, a group where people were shown the songs at random, let's say, completely at random, with no information whatsoever about how other people listen. And another group were exactly the same, but people had various kinds of information, like ranks, like for instance, in this case, this is on the top, the song that the most people have listened to so far, right? So it's a bit like what you have on Amazon, I guess. You have the top or other systems, right? So social pressure, no social pressure. And they made a very interesting experiment. I don't want to go into details. But the conclusion is, when you have social pressure, you have more inequality. It means that the hits are much bigger than when you don't, right? So you have super mega hits. When you don't have social pressure, there is no super mega hits. No Beatles, no Ed Sheeran, nothing. Well, there is no nothing, but there is much less. When you have social pressure, you have increased unpredictability. What does it mean? It means that if you do several times the same experiment, the hits are not the same. So if you don't have social pressure, all of us are on a different planet, right? We listen to the same song. There will be some hits. That is, some songs which most of us prefer, some kind of non-uniformity of preferences, right? Because there are simply songs which are better than others, in some sense. But if we do the same in our world, each time we replay the time, the hits are different. Why? Because it's like this. It's, it's preferential attachment plus early adopters. This creates some kind of chaotic thing. So it means that the hits are hits, but not because you like them, because we are together in the same world. And when you have social pressure, as opposed as when you don't, you have this thing, increased convexity between quality and success. It means that if a song is slightly better meaning without social pressure, then the difference in popularity is huge. So it's really very convex. Conclusion, we don't understand what's going on. Conclusion, you cannot take popularity. Popularity is number of streams, number of views on YouTube, number of CDs that you have sold, right? You can measure popularity very well, but you cannot take this as a ground truth, because it's a completely chaotic measure of the quality of the whatever you're trying to measure, right? Being music, books, and everything. And so when you read this paper, you really wonder, I wonder, but I am a huge Beatles fan. I mean, I could really kill someone just to meet Paul McCartney. But in the end, you say, well, no, it's not me. It's the society. I'm part of this group, and that's it. Is it me? Is it not me? Is there anything as intrinsic quality of music? So what they say is, they don't say there is no intrinsic quality. They say there is, but it is amplified and chaotized, if you want, by social pressure. Social pressure is such that in the end, you're not really able to track the intrinsic quality down using this data, right? So that's an interesting problem, because no function, no data, no reliable data. Still, in music, people try to be creative. That creativity is a very important notion. It's to such an extent that if you look at what happens in the music industry, in the ontology, the concepts that people have, basically they have these 2 or 3 concepts. So there are new things, original things, and there are covers, which are copies, but legal copies. So you have a song, and I'm going to sing another version of that song. That's a cover, right? And then bad people doing plagiarism, bad people, trials, and that's it. And if it's not, then it's new, right? So that the ontology of with three concepts. That's for the lead sheet, and I will give you some examples. And in the audio domain, you have only original and plagiarism. That's it. So let me just give you an example. So you know, maybe you are much too young. You were not born, I guess, in this. But you know Chic? No, well, I don't know why I asked the question, actually. So this is Chic, right? Okay. Then 82, 2000, 18 years later, Mojo is a French group, two people 18 years old, in their kitchen, they did this.
Lady, hear me tonight, 'cause my feeling is just so right as we dance.
I could play it for a very long time. It was a huge hit in the world, and not only in France. And it's exactly, I don't know if you've perceived that, it's exactly the same guitar riff that has been reused, transposed a bit faster, but with different structure. So that's called, it's called audio plagiarism. You copy some piece of audio, you can transform it a bit, and there is lots of this now in electronic music. Sometimes it's legal if you buy the right, sometimes it's not. But that's plagiarism in the domain of audio. I want to talk about plagiarism in the domain of lead sheets, publishing, songs. That's very interesting. To give you an idea, so do you know, even your father, your parents were not born, are so young, these guys nowadays. This is the problem with youth, is I don't belong to it anymore. But 57, the chiffons.
He's so fine.
Right, so this is okay. Nice song, lots of covers. This is a cover of Is So Fine. Same song, right? Different voice, rhythm, instruments. Right? Right. That's a perfectly legal cover. This guy actually gets the publishing royalties. Yeah, I will talk about science after, but I want just to set up the context. It's very important. And then, you know this guy, George Harrison? No, I don't know. The Beatles guy. He did this in 71.
My sweet Lord.
My Sweet Lord.
My Lord. My Lord.
This is the A and then the B.
I really want to see you.
Right. So it's pure plagiarism. Not pure, but very heavy one. And that was a huge success, as you may have heard, in the world. Much more than this, actually. So there was a trial, very interesting trial, where people really talked about music. Why is it a plagiarism in the end? Same chords, same notes, not really exactly. And the way the conclusion was, yes, it's a plagiarism. But this song existed. So there were covers of this song, not this one. Billy Preston. Right? But to make things a bit more complicated, people started to have fun with this situation. So for instance, Jonathan King, a British guy, of course, he made a cover of He's So Fine, using exactly the sounds and instrumentation of this. So this is exactly the intro of this song, of George Harrison, but this is this song now. So it's not My Sweet Lord. All right, so what is the status of this? Not very clear. It's a cover of a plagiarism of a song, but it's also a plagiarism in terms of sound, audio, of, let's say, instrumentation plagiarism of the original song, etc. And so what happens, and this is the conclusion of my talk, really, is that before AI, you had this situation. Now with AI, we will basically introduce a new category of creative works, which are not plagiarism, definitely not, which are not covers, even less, but which are inspired from, right? And this category has always existed somehow, but never in the field of, in the legal world or in the industry. And with AI, we are basically creating this category. And it's very interesting, because there are lots of very interesting stuff going on here. And I've tried to show. So coming back to AI now. So what happens in AI when you use, well, AI I should not use, but I should say machine learning. For creative works, what you do is sampling. So basically, you have a number of, you have a training set, a set of songs, which can be scores, which we call lead sheets, or audio files. You train, you give this to some machine learning algorithm, you train. So this is going to build a model that's kind of an abstraction of this, which is going to capture everything that's basically in common with all these things. That's training. That's what any neural network does, or Markov chain, or whatever. But then when you have this, you generate, or you sample, or you create an instance of this. By definition, this thing will have exactly the statistical properties that were captured coming from this, by definition. That's, I mean, if you want to do this with a neural network or Markov chain, it's now a few lines of Python, really. It's very easy to do. So what people do is training, sampling. And they have been doing this for a long time. So in '56, actually, Markov chains were used for the Iliac suite. It was exactly the same. You had a bunch, so it was very rudimentary, I mean, but it was the same idea. You had a bunch of back chorales, and you just take the pitch, and you build a Markov automaton, and then you go through this with random walk. And you generate what you have heard at the beginning. So today you have other models. So we have worked a lot on constraint and max entropy, and also now neural networks. But the idea is exactly the same. That is, you have a training set, you build an abstraction, and you sample, right? And there are lots of technical complications that occur, not when you do that, but when you try to constrain this. You know, try to say, oh, I want the whole thing to be in C major at the beginning and C minor at the end. That's going to raise a lot of technical challenges. I will not talk about that, but this is why so many people now are interested in this domain. And so another way to look at this and to see, to understand what's going on is a concept, and I will show you some examples just after that comes from Aristotle, which is called Hylomorphism. So it's a very simple idea that it's a philosophical stance that everything in the world, every object, every people, is a combination of matter and form, right? Well, yes. So this is matter, or you can call it texture, leopard skin. So there is no beginning, no end. You know, it can be cut into or multiplied, the same kind of objects, like water, right? And then you have form, which is exactly the opposite. You have a form which you can call also structure or constraint. And so that's a very old idea, but what is very new, that's since, let's say, a couple of years, or maybe a bit more now, technologies have been developed to basically separate these two things automatically. And that's very new, because otherwise it would be really hard. So if you can separate, you can also recombine. The same process, basically. So if you say, okay, I want to have the texture of a leopard and the structure of a rhino, please put them together. So that's a new thing. That's a new object. Is it a good object? Is it an interesting? I don't care about that. This social pressure, we'll say. But it's new, and many works of art are actually created by combining a texture with a structure that was not designed for that purpose. It's one of the patterns. I'm not saying it's the only one. It's one of them. So what's new is that you can do this in one click now. Before, it would require a lot of training and skills. So this is a picture, but you can do this in many other domains. So, of course, if you say, oh, that's quite interesting, then I would try to make another one, and maybe you can create a style and so forth. Again, that's not my topic today. what I want to say is that there are technologies to do that. These technologies do not have any idea or intuition. It's just a process, right? So what I want to do now is to show you what you can have when you do this with music, and with audio in particular. So what I will say, and I will take. So you know the Beatles. So you know this song. So who does not know this song? You? Out? Michel, okay. So I'm not taking Michel the sound, taking the score of Michel, right? So the notes, the chord progression, and so forth. And I'm saying this score is a structure, like the rhino, right? And now I'm going to look at textures, like the leopard skin, so I'm taking this. You know Stevie Wonder? Yeah. All right. So you know this song? Very nice harmony, choir, voices. This is done in the 70s. I have no idea where, what. I'm just listening to the sound, the texture, right? I'm not listening to the harmonies. And anyway, they have nothing to do with the harmonies of Michel. It's just the sound, like it's a leopard skin. And I do the same. You know Michael Bublé? Yes. So, Michael Bublé.
You're a falling star. You're the getaway car, you're the line in the sand.
I don't care about what he says. I don't care about the song. I'm interested in the voice texture, or again, not the structure, right? And so audio style transfer is about taking these things and mapping them to the score of Michel or the score of whatever. So extracting, if you want, the style, the texture from the structure, removing the structure, putting another one. So if you do this with Michel, you get this.
In this carousel, in this line,
right? Is it good or bad? No. We talk about this later. I think it's pretty good, to be honest. But that's not the point. The point is this is one click. Well, actually two, because you have two tracks, right? It's not 1 week of work. It's one click. So it means if you now jump to the conclusion that we will have later, that the artistic act will not be about trying to understand how Stevie Wonder wrote this harmonization and then try. No, it will just be about choosing. The act of choosing this Stevie Wonder extract and mapping to that lead sheet, that's a creative act. Because you can imagine a number of combinations you will have. Millions and millions of stems, millions and millions of lead sheets, plus the one that you want to write. It's billions and so there is a problem in the act of choosing, which I didn't mention. But what is new that AI can do the work of making this work. So. So you know, by the way, Frank Ocean, Super Rich Kids, is a great song with these chords, very slow, plinking harmonies, which are not quite the harmonies of Girl from Above, but still the system is able to do something. One note samba also. I will go faster, but this is one click. It's not. There is no cheating. Just you select Girl from Ipanema, the score. You select this Marvin Gaye's voice. You click, and and that's audio style transfer. Okay, we can discuss the details. There are many ways to do that. So when I was doing this project for the ERC, they asked me to reharmonize the Ode to Joy, which is the European anthem, as you know, by Beethoven. So I did a number of reharmonization, which I played at the European Parliament. And so because I'm a big bossa nova fan, I made this one. I love a cheesy bossa nova. I'm like this. Like, I'm sorry. The violins. Okay. So that was so much for audio style transfer. But that's about audio. That's about sound, textures. That's not about composition. So, because in music you have this thing which is a bit strange, is that you have these two levels. When you compose a song or when you compose a symphony, usually you have the score dimension. You write notes on a sheet of paper, and then you have the orchestra or the band playing the thing. But you have these two dimensions, right? And in pop music, it's the same. In electronic music, it's a bit different because people do not really care about the score dimension. But still, there is always the two dimensions somehow, somewhere, to deal with. So I showed the audio. Now, just to talk briefly about the score, the symbolic dimension. So this is the work done by Gaëtan at Jerez during his PhD about Bach. By the way, the Iliac Suite was also about Bach imitation, right? The thing I played at the very beginning. But that's basically what we can do 62 years later. And it's very different. I mean, technically and also the results, but it's still the same idea, right? So Bach, I mean, in this case, a score is actually 4 voices played together, right? And the trick and the difficulty is to learn how the voices go together precisely. It takes like 6-8 years to learn if you go to a concert. It's quite difficult to learn that, really hard. So to learn the way all these notes interact horizontally, vertically, and so forth. So now with architectures like LSTMs and the combinations of these things, you can build a system, this is what Gaëtan's done, that basically does nothing else than being trained on a number of chorales, and that's it, without any musical knowledge at all. And then once you have this, you can sample. So this is an example of a real Bach chorale. Okay, so this is played by organ, real Bach. So what you can do now is you can take the soprano, so you keep exactly, this is exactly the same, but you reharmonize in the style of Bach. And what you can see that, well, so I will play it, but what you can observe that the system has indeed learned all these rules, which are really hard and tricky, and is making a quite different harmonization, but very nice. So here it's played by humans, flutes, right? So what is generated is this score. Okay, it's on YouTube if you want to listen. But so what the question is, it's very nice. Don't laugh. It's not, you can laugh later, I will tell you, but not now. This is very serious. So you make tests. You play real Bach, you play deep Bach, you play other model neural networks, other models, and you ask, is it Bach according to you? And you do this with beginners, people who don't care about music, people who care about music, and teachers at the conservatory who know about music. What's funny? I'm not sure. There are people who know about music. And this is real Bach. Basically, deep Bach is here, so it's really hard to tell apart the real from the fake. Say fake, not really fake, but another thing is that if you are a teacher, you know everything, you know all the chorales. So if you listen to a new one, you know it's not Bach, because Bach is not in a state where he can do more chorales. So there is a memory effect that makes it very hard to test these things. Because experts, by definition, they will always say it's not the right one, because they know everything. But still, it's very good. You cannot easily, it's very hard to tell apart, right? So you can do this. Especially with Brexit, it's a nice piece to play. You can do this also, coming back to Parliament. So that's a more difficult thing because it's a jazzy interpretation of Ode to Joy. You can hear lots of various. I don't have the time to explain, but that's a very interesting problem for music and AI because you have to make something that's a bit different from the target, right? Like a jazz player, you know, you ask him to play Yesterday, he will play something that's a bit like Yesterday, but we add a lot of stuff, right? And that's not a very well-defined problem, but it's what people do. So it's interesting. Okay, so you know the Beatles? Yeah. So I will talk a little bit about how this AI generated this song by the Beatles that we made, Daddy's Car. So, you know this song? No, because you know sometimes when you drink, I mean, you can forget stuff. So, who is a guitarist here? That's a guitar, right? So, do you notice that in this guitar there is a note that goes down F, like something? I will play it. Don't stay here. Okay, so that's a pattern that the Beatles did a lot. Keep this in mind. And so what we did is we fed the system a number of Beatles tunes. A journalist once told me, "Oh yes, you fed hundreds of thousands of Beatles tunes." I said, "Unfortunately, they wrote only 200. But it would be so nice if I had 200. I would not be here." So we fed with about 40, right? Scores, not the sound. And the system generated a new score, which we call Daddy's Car. The lyrics were done by hand. It was in 2016. And most of the orchestration, a little bit was done by AI, most of the rest was done by hand. But I want to show what AI did, which is interesting in there. So this is a song. I mean, I cannot play it. Again, it's on YouTube. It's easy to find. Sorry. I have to skip. So what I will do now, I will play an extract that's more like in the middle of the song, a few seconds, right? The rainbow led me to the sun. Did you notice something? What? Yes. But since you are the only one, I will explain what happened. I will take this thing and I will transpose down like a fourth or fifth, I'm not sure. Okay, now. That's exactly the same harmonic pattern. It's a chromatic descent, and you have both of them. So they sound together perfectly well. You probably did not even notice because it's exactly the same harmonic pattern. And that's a pattern that the Beatles used a lot. And not only them, actually, but many people then. So what did the AI do, basically, is first to detect these kinds of patterns. And this is why where AI is very good, is actually sometimes better than humans, because the patterns, of course, are not exactly the same. And then re-instantiate those patterns, but in a new context. And creating a context where the patterns will be, by definition. This is actually sampling, basically, but it's very smart. And it's a bit like, you know, what a guy who would have been fed only with the Beatles and the Beach Boys in his life, maybe this is the kind of things he would have done, right? Because, you know, you have these patterns in your head, you just reuse them in some quite creative ways. But you do not invent new patterns, you just but this is what most musicians would do, really. So again, I wanted to show that to really be very precise about what the AI did in this case. And the song, I think the song is pretty good. I mean, it's not as good as the song, the Beatles song, the 2 million songs that they wrote, but but it's not bad. And unfortunately, when the press, you know, talked about that, they talked only about the AI. No one talked about the actual music. As a song, it's pretty good. It's pretty good. That's something that should be said because at the first time, right? I mean, like the Iliac Suite did not make it to the charts, right? It's interesting to listen to, but you cannot distribute this music. I mean, after 10 seconds, you have enough, right? So it's really hard to make a song that can be sustained for even 3 minutes, right? So now a few words about the end of the project. We said, okay, we have all these technologies. Most of them are published. If you are interested, we can talk about them. But it's basically what I show. Let's make a real album. So what is the difference between a real album and the rest is that, you know, I didn't want to do demos because I was tired. And I have become very good at demos. I can demo anything. And people say, oh, that's fantastic. But you know it's crap, but you demo, you're good. So I was thinking, let's do something real. The challenge is you make music with real musicians. You produce it with real producers. You distribute it on real platforms. And you wait for to learn what people like, or if people like it or not. That's a very big challenge for AI. Very big. And Hello World is the first album that was produced ever with AI, or with actually computer science, that was actually distributed and which has some success. Currently about 6 million streams. It was quite good. I will just give you some examples. So one of the songs I like very much, the way it works is, first of all, you feed the system with something. You don't feed it with millions of songs. First of all, it does make sense because all the songs are so different. And so when you are an artist, usually he has an idea. He wants to make a song that's more or less like a bossa nova, electro, like this, like a songwriter song, like whatever. But he has an idea. This is a small number of songs which represent what he wants to do. So what we did is we put some bossa novas from the 60s, like this one. Maybe you know this one.
A insensatez que você fez.
Okay, it's a very nice song. So here the song is sung by John Gilberto, but we put the scores, right? And if you look at the scores, even if you don't read music, you can see that there are very long notes, and then da-da-da-da. So chromatism, you can see this as Brownian movements. Very small intervals, right? But it's very nice. And then here you have these harmonies which are incredibly sophisticated, in fact. And so we wanted to create something like this. Same kind of texture, right? And so I will play it, but so the system generated a score, and then we played the score with style transfer, with audio style transfer. So to do that, we took a piano track from an existing song, which has nothing to do, and the voice of King Crimson. That's our choice, artistic choice. Don't laugh a bit about it, because that will be the answer of some of the questions after. And so, so you understand what happens. So AI generated a new score, and then we do style transfer on a number of tracks. So this is a score generated. So even if you don't play it, you can see there are also long notes and chromaticism. The song is very different, but it has the same kind of, at least these two characteristics, which I picked up, but there is maybe others. It's just because I see them. So that's the song.
He turned around in fear, will carry you on the breeze if you turn to appear. He entered on the wind, entered on the wind. It's not clear why.
So I stop again. I want to have more time for the rest, but you could hear the long notes, the Brownian notes, the harmonies, and there is not a single millimeter of plagiarism. It's new, completely new, and it's very hard to do these things. I mean, I've tried to compose bossa novas, really hard to make. So it's really a very interesting. One of the songs. I want to just give you an idea about one of the first songs we released in December. So it was composed by Stromae. So Stromae is a big name in France and in Europe, I don't know, here. and he had stopped making music actually after his first album. He had a huge success in. And then he came, and then he said, yeah, was really interested. So the system really challenged him, and he said he wanted to do some music from Cap Verdean music. So this is what he fed in the system, right? And well, there are on the record lots of details about exactly what we put in the system, what was generated, and all that. And at the end, we had the melody sung by Kesha, who is a quite well-known singer in the States, right? And in the end, it was produced by the producers of Stromae by hand. So when I say produced, I'm talking about sound engineering, compression, sometimes adding a few things here and there to make the song really, let's say, listenable by a wide audience. So that's the result, I guess, here.
I am the shape of a whisper that I am.
Just play a few seconds.
The whisper of a good man. Filling the space where light goes missing, but I will be missing where the night lands. I'm a whisper, but it is not what I am. I'm a shadow, but far from the darkness I ran. I'm a whisper, catching all whispers in my hands. I have done what no man or shadow can. Will you follow me, good man? 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 Will you come now as I was, be as I am? Follow me as you are, but I will say hello, shadow.
So here you can recognize the Cap Verde rhythm coming in. And I don't know if you have noticed, just before I stop, there is the whoosh, so that's, we added. Because I don't know, if you don't put this in a song, no one listens to it. No, I don't know why, I don't like it. The rest is generated, and if you pay attention to the melody, it's actually quite unusual. The intervals, the rhythm, it's not something you would write, right? It's what the AI did, and that we choose, and that Stromae chose. That's a session in the studio.
C'est le même passage qu'entre la musique organique et la musique électronique, quoi. Ou la composition électronique. Enfin, c'est une espèce de gap. C'est ouf, demain, c'est sûr, on fera tous de la musique comme ça, en fait.
So he said, tomorrow, it's crazy, we will all be making music like this. So he was really one of the best ambassadors we could find. Okay, and I recall he had stopped making music. So it means that it's a technology that also pushes people, creates the flow. That's why it was called Flow Machine in the first place, actually. So I think I don't have much time. I want to still talk a little bit about the next steps and show something. So these are, I don't think I will play them now, but these are extracts of all the 15 songs, which act a bit like what is called earworms. So earworms are these songs, you listen to a song and then you have it in your head for days, right? And you cannot get rid of it. So that was and to me, I think it's a huge quality of a song. If a song is good, by definition, it stays there. So many people study earworms, try to know if there are features, and the result is there is nothing we can understand. We don't understand anything. But what we have observed, and we don't know why either, is that most of the songs have a kind of earworm thing somewhere. That is a thing that when you listen to it, stays there. And we don't know why, but it's probably because the technology is such that it creates things, again, that are not completely natural. They are a bit strange, but yet, because of the statistics of all these models, this strangeness is somehow compensated by everything around, which is, more conventional, right? And that's a very interesting subject. And it's more like a question than an answer. But what is an earworm, and how can we control AI to build these things? Knowing, again, that we have very limited ways to measure anything, right? But that's another reason why it's interesting. I want to conclude. Nowadays, every day, basically, you have new papers on these things, new technologies, you have new gadgets. Gadgets, I mean, new architectures like variational autoencoders, GANs, and many other things. And all these things are going to contribute to solving some of the questions, the basic question of music, for instance, making a variation of a motif. But a deeper question is when you write music, what is a good motif? So it's easy to compose one bar. But among the billions of bars you can compose, only a few of them are robust enough so that you can use them, transform them into a song. What does it mean? How do you measure? How do you do that? So there are lots of ways to investigate all these issues now, which are very exciting. In some sense, a bit too much, because I read every day there is something new. I make some publicity for a book that's forthcoming. We wrote about all that. And I want to conclude just on one very strange thing that, next step, what's next? Well, many things that we don't understand, but one of the main problem, I would say, is structure. Like, how do you make something that's long? Well, in pop music, long is 1 minute. Huh? Well, even you have an A, how do you make a good B? No one has any idea about that. But that's about structure. Do you repeat the B 3 times or twice? Is intro 15 or 20 seconds? That changes everything, but so, structure. And I conclude on that. It's not our work at all. It's Diana Deutsch. It's quite old. And she noticed that the mere fact that you repeat something creates musicality. So somehow it is an old idea, but if you listen to this thing, it's really impressive. So I will play them. So basically, the first thing you do is you listen to, there is a girl talking in English, right?
The sounds as they appear to you are not only different from those that are really present, but they sometimes behave so strangely as to seem quite impossible. But they sometimes behave so strangely.
Let's repeat it.
They sometimes behave so strangely. 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 So strangely. So strangely.
Okay, so that's the training part.
So strangely.
Now what we are going to do is we are going to play just the end.
The sounds as they appear to you are not only different from those that are really present, but they sometimes behave so strangely
Like
as to seem quite impossible.
It is music. Sometimes that behaves strangely. You hear it as music. Why? Because it was repeated. And you can do this experiment easily yourself. It's very impressive, and it's a bit worrying in some sense for research. Because if you push this very far, it means that basically you don't really care about the notes and the harmonies, C major 7. Just find the right way to repeat it. Okay, I'm just exaggerating. But what we really don't understand today is how the structure problem, repetition, variation, structure, plays, or the interplay between this and the music content, the streams of notes and stuff that you learn and that we know how to do. And that's a very, very fascinating problem, because obviously the reality probably is that there is a very complex interplay between these two things. It's not like you can do either one or the other. And that's something I think we know nothing. But we have lots of tools now to investigate these things. Conclusion, why it's interesting, you don't have any well-defined function. Actually, you probably don't even have a function, even ill-defined, because I remind you that the function is something that returns all the same result each time you call it on the same arguments, right? That's not the case with music, because of social pressure, but also because of the psychology of humans. So if you listen to a piece of music 20 times, your appreciation is going to vary a lot, sometimes goes up. So I've studied a lot of psychology of music about that. That's called the mere exposure effect. What happens when you listen to the same thing different? So you have 3 kinds of papers. Papers which say that the more you listen, the more you like. papers which say the more listen, the less you like, and papers where say there's a U curve. Conclusion, we know nothing. Right. So that's very interesting. So no function, even less differentiable, of course. And popularity, which you can measure very easily now, is not a measure. As you know, popularity, significance is completely different. I mean, it's not completely, it can be interesting, but it's... So conclusion, AI is great as a tool to give to artists so that they can have new ideas, they can generate new material, new melodies, new harmonies, new rhythms, new combinations of sounds, new combinations of all these things, crazy stuff, maybe new structure. It's a tool. It's not going to be a system where you click and you have a hit. I stop here, because I think we'll be killed if I continue. But really, this is a whole take-home message. AI is a tool, a great tool. Thanks. Oh, no, no, no. The vinyl.